So hello everyone, welcome to our new video. In the previous video I discussed with you about the implementation of graph using linked list for weighted graphs, right? Now there whatever the values we were taking, all those values were integer values, right? The nodes, those nodes were integer nodes. Now what if I have to represent different data type of nodes? Suppose I may have a character. How the data is stored in a Google map, we have the names of various locations, right? Now those locations, they are strings. Now how are we going to do that, right? So we can do that by simply changing the data type here. Now my question here is it necessary to do a different implementation, to do to write a different program to all those different data types? No, we can simply create a template here. Okay, so just have a look here. I have taken the same program what we had before for a unweighted, directed and undirected graphs that we did. Okay, the adjacency list, the same thing I have taken here and I have named it as something which will be generic. It will be generic depending upon what type of value we are passing over there. Okay, so here calling the header files, that remains the same in both the cases. Then creating the class here as graph, that is also same. Now here previously we had an unordered map which was taking values as an integer value, and along with that the second thing was a list of integer values, right? And the name was adjacency list. Here also I have this, and everything is same, an unordered map, adjacency list, ADJ list, and here instead of integer I have written there as t. Now what is that t? Now t, I have created a template over here, template type name t. Instead of giving this name as t, you can give anything, a, b, c, d, e, f, g, h. Okay, any type of value you can write there. Okay, that will become the data type. Okay, then after that the function that we had here, void add age. Here we were taking integer u, int v and boolean variable direction. Here instead of integer it is simply replaced by tu and tv. Okay, and the direction thing remains the same, and the entire thing how we are going to enter a new element by using the pushback function remains the same. If the direction is 0, it means if the graph is an undirected graph, then in that case the opposite one also has to be done, pushback u has to be done, that also remains the same. Then printing the entire adjacency list, that also remains the same here. We have taken a for loop here, right? Then inside this we have auto node. Auto node, here comes the actual use for the auto keyword. We don't know what type of value are we going to enter here. It can be integer, it can be character, string, float, anything. Here this is what is coming in actual use. The auto keyword, depending upon the type of data that we are using, depending upon the list, this variables, node, neighbor, they are going to change their data type. If we are passing integers, so they will be acting as an integer. If we are passing floating point value, then node and neighbor variables, they will become a floating point variable. If we pass a string, then they are going to become a string variable here. Okay, so these all, everything remains the same. Okay, now this was the main function. So now this was the main function that we created, right? Now let's see the same thing here. Now here also I have something similar. Okay, here we simply created a graph G, but here while creating the graph we have to specify the type, the template here. Okay, if it is a character, then write here as character. If it is integers, then write here as integers. May it be string, then write there as string. Now here as it is characters, so I am passing here the character values here, a comma b. It means we have the nodes a, b and c there. We have ages from a to b, b to c and a to c, right? So this is the thing. So this is all about the generic implementation. Instead of writing here as integers, I have created a template over here. I have given the name of the template here as t. Then the map passing the template t here. The function, instead of writing integers, it is t again, and here inside the main function, instead of simply writing there is graph g. Now depending upon the type of data we are giving the inputs, if it is characters then characters, strings then strings, integers then integers, floats then float, etc., etc., whatever may it be, we are simply passing these values, and then I am printing the entire adjacency list, okay, using the same print adjacency list function here. So now let's execute this and see how it works. So here we had three different nodes A, B, C. These were the edges. The edges were undirected. So here for node A we have edges to B and C. For node B we have edges to A and C. For node C we have edges to A and B, and the same thing is getting represented here. So this is how we can do the implementation in a generic way, so that we can easily use this implementation rather than thinking upon that what is the value, how we are going to do the implementation. Now this is all about implementation of graph using adjacency matrix and adjacency list as well. In the further videos I will be showing you that how we can traverse to the graph, or we can do the other different implementations, okay. So to stay tuned, please do subscribe to our channel and don't forget to press the bell icon so that you get a notification whenever we are uploading a new video. If you have any doubts or any questions in this video, then please give us a comment in the comment section. We will definitely get back to you, and share it with your friends if you have liked the video, and don't forget to press the like button, because that gives us a motivation to record a new video every time. So thank you very much. Till then, keep learning.